Hello and welcome back to module number 5. And today agenda we're going to talk about chapter 7 in YouTube textbook, and we're going to talk about spotting differences, and then we are going to talk about deviation analysis, and again it's based on our textbook. And in the software department we are going to introduce my favorite tool, RStudio, and what it can do in order for you to generate the visual analytics images. Okay, but before I will start discussion what is deviation and what is separation, I want to make sure that I am coherent with regard to why is it so difficult to lay out visual terminology that will help us to understand. Because when the question I want you to ask at all time is, are you using the right chart, or what are you trying to show? And if you are, for example, going to talk about distribution or trends or comparison or relationship between value, there is some schema understanding of what type of visualization it can entail. So again, our textbook help us to highlight those differences and how can we match those differences in order for us to have the best visualization that is communicate to all people. So spotting the differences is the idea that our textbook in chapter 5 you talks about comparing across multiple variables. And the idea here is, again, to those who did not take my statistical class, we are talking about independent versus dependent variables. Those two types of variables have different names, and usually when we are talking about cause and effect, this is part of the terminology with regard to the independent and the dependent and how it play out with that regard. And so this is the issue with the statistical methodology and how to apply or how to set it up. However, and again, this is about the visualization, ways to visualize comparison. And the idea here is that inside, if you will click inside the image, it will take you to data viz catalog that allowed you to see what the recommendation with regard to type of visualization that best fits comparison. So the idea here is that he lay out quite explicitly, or in a lot of what type of search you are doing and what type of visualization is best fit. I highly recommend that you visit this website, try to learn what it can recommend. One of the things that I have not yet discussed throughout the past module is about stack bar graph. I know from my own experience, a lot of people really like it, and like it because it's really get their attention and talk about what to capture their attention and how it does that. It also allowed us to add a lot of variables into the bar graph with regard to the adding the visual or the colors, add the variable to it. And so it gives you the ability to have multiple variants in analysis in this type of graph. However, the major flaw of this type of graph, it's become harder to read and to understand each segment. So also comparing each segment is really hard because you don't see what's the difference between 2 and 1 or between 16.7 to 33.3. And so this causes problems, and again, this is something that we need to be aware of when we are using this type of visualization to tell a narrative or to tell a story. So the use of multivariate analysis to spot the difference between variable is one of the most important assets of visual analytics, according to our textbook, is to find the differences and highlight them and use the visualization. He doesn't give you a specific tool or specific methodology to do that. It's up to you to discover. This is the essence of visualization. We always discover, we always work to better communicate, to better share what we found in order for us to get feedback and then improve it again and again until we have something that is understood by everyone else. Which brings me to our next subject. What is deviation analysis? According to our textbook, again, our second textbook, it is the measurement of the difference between any one number and its mean. And so, again, the issue of differences is the key element where visualization can help a lot. So the idea here is, what is the point of deviation analysis and display? So he made a comparison between current target or sample point of time or standard in order for it to apply to it. And he says that the deviation analysis does not require fancy visualization. The two best graphics for display deviation analysis is bar and line graph. In both cases, the graph that features deviation should have reference line, the set of value to which it being compared. One of the things that he talks about is bar and the deviation. And again, this is one way to display it. The issue here is that in this case, we cannot give directions or layout or give labels to the value because it separates them totally without the real value of it. So this is something that you need to be aware of. The other one is line bar, and line bar is quite proficient in showing the comparison, and this is something that is really common to use, and usually they use it in different types. Example, stock markets or overall performance and so on and so on. So line bar and deviation analysis is really key important. But how do we do how do we do deviation analysis, and what do we do in order for us to find those things? So it stands for the variance and the standard deviation in statistics. The variance, again, to those who do not took my class, it is about the measurement of data points different from the mean. So I lay out for you exactly how to find the mean, what does it entail to find it, if you will go through my PowerPoint presentation that you can download and find a way to present the data numerically. How do we calculate the mean? Usually there is a formula that we often apply, but the formula is divided into two: the population, the entire population variance versus the sample variance. And in this case, all of that is part of how to calculate the variance into the mean. And so this is something that I want you to have in mind with regard to population is capital N, which is the entire population, versus the sample variance is n small n minus 1. So I give you an example, I lay out for you exactly how it applies and what it consists of. So standard deviation, the measurement of variance about the mean, and again, sample standard deviation versus the population standard deviation, and to find the variance itself with that regard. So again, this is where you do it step by step if you will not use calculator or software applications such as R or SPSS in order for you to do that. We also need to consider or to have in mind, back in our mind, about the empirical rule of data. The idea here is that 68% of all score fall within 1 standard deviation of the mean. And the next step, or the next, is the 95%, and the third is 99.7. We need to report on that when we will do the visualization, and it's important to have that in the back of the mind when we apply that. So here's the same information, but this time information is displayed in different format. And again, it's up to you, because you are going to be the creator and the person who is in charge of communicate the result of the deviation analysis. To illustrate this idea, the textbook make the case of refer to the actual money that's spent versus the budget. And again, this is two way to capture that. What do you think best work? The one that is straight or the horizontal? Everyone has an opinion. Everyone has ideas what works best. But in R, we can also do that, and we can do that with using it with regard to display it in time frame and to apply more specifically. So I'm going to change the subject now from variance and multivariance analysis to the introduction to RStudio and the idea what R bring into the game. So the background, R and open source R is open application, and this is the framework that we are working. My idea is that every software needs to be open. However, not all the software are open. Example, Adobe Illustrator. You had to purchase or you had to receive grant from the university in order for you to use it. Those are not open. Microsoft Office is not free. Comparison, open source is the ability to have application that you as a user can use it as free without paying anyone fee for that, but in return you need to contribute something to this environment. And it has a little history, even though the history of software usually focus on software that were sold to the public. It started as an open, and it started in Bell Lab that does not exist anymore. And Bell Lab was purchased by AT&T, and then AT&T dissolved it and said there is no need for new software application because everyone is using Excel. And again, there is a lot of default, a lot of things that Excel cannot do well. One of them is visual analytics. And so the story of the project R is that in 1980, they created an S language, and they did not achieve popularity in the market in compared to Excel. And in 1995, two professors from New Zealand took the S and converted into R. Why did they call it R? Because both names started with R, Ross and Robert. Both people I met, both people are still alive, both people still trying to promote the R and trying to create more diversity into the R. So the R language is a language that allows to the user to actually write the code and to apply the code. To those who are not programmers, who do not have experience with programmers, I will show you how to overcome this problem with the R, and you will use GitHub, and I will talk about that later on. So the R language, like any other language, has a basic syntax and structure that allowed us to have ability to create statistical analysis and be able to convert those module or statistical module into programming language that can be run. So R basically is an object-oriented language where the objects are the data structure that consists of data fields, and method in order for us to get the interaction to design application and programming languages. But in compared to what you are familiar with Excel, that is only one Excel and you open a file of the data, that's it. In R, we have different application, different environment. We have the R packages. R packages is everyone can create, and I also created packages that allowed to do specific type of analysis. Example, I did in my work, I did Lotka's law that measured author's contribution to the field. So everyone who is using the package can install the package in the R environment and run the package and use the example that I gave in order for him to see if it fit to his or her data set and see if that it can be run. That's the idea, that we can use any package for free in order for us to do that. So how do we start with R? We are loading two applications. One is called the console, and the console is like the old days of DOS or the Unix console, and it looks something like that. And the other one is to install the Windows environment or the Mac environment called RStudio. It's a real company that sells its platform to user, but if you are using the software, it will be free. So this is again, the issue of free is really important, not only for me, but to the R community that always looking for ways to create our own visualization. Please do not install the R server because you will not be able to use it. Only use the software. You need to know what type of desktop you have. Is it a Mac or a PC or Linux? And by using it, you are able to download the application. The R interface consists of 4 windows, and I will talk about that in 2 seconds. And you have a script where you write your code. You have the console, basically where is the engine of the R. And you have the variables, the workplace, and the file history that you are doing it. And you have where you're going to see the visualization that you are creating, where you can see the packages that you're going to install and how to install that. And you're going to see how it runs. The basic functions in R is basically summary, history, and I will provide you with today assignment. It will be basic function in R, and to those who already taken my R classes, I will expect you to do something else. But to the majority of you, I want you to learn how to apply R to generate basic visualization. So R, as I said, is basically a calculator, but a calculator more advanced with that regard that allowed us to write a formula and run a module out of it. So again, how it layouts again and what it is. Okay. Right now, R packages are right now the number of R packages that are listed in the repository is around 60,000 packages that people created. So the packages that are specialized in visualization are part of it. This is only a small part. I could have come up with 120 or 150 packages that actually generate visualization. However, the most famous visual analytic packages in R called ggplot2. And the idea of ggplot2 is that it allowed you to do things like that. And this is something that Excel, SPSS, or any other platform does not allow you to do. And this is where the powerful of visual analytics come to life, and this is where the power of visualization can be displayed in order for you to do that. So in this class, I don't expect you to generate new code, but if you want to search for a code that will generate the visualization, we will use the GitHub, and I will refer to the GitHub as a resource for you to do that. So what is a GitHub? Is a version control. What is a version control? We are trying to have two places where we store the file that we are working. And in order for you to do that, it is the way for us to store the information not only on a desktop, but also on a server that everyone has the accessibility to see what we are doing. And by doing that, it is really important that we share this information. So you will install the GitHub and be able to have that and be able to do that. So that's it for today's module. I hope you enjoy that. I hope that you be inspired by R. And again, if you have any questions, please do not hesitate to come to my office or email me or Skype, wherever it works for you. Until next time, have fun.